Hello and good day, pre-algebra. We are jumping ahead a little bit in our unit to our final objective of the unit, which is CO48, using similar polygons to find missing lengths. Before we recorded, we had a little discussion on what the word similar means. In geometry, we have congruency and similarity. Congruency means same size, same shape, everything's the same. Similarity means what? I bet you know. Similarity means what? You just said it like 45 seconds ago. They're proportional, okay? So similar polygons are two shapes that are proportional, which means that a scale factor exists between their side lengths. Okay, there's a scale factor exists between their side lengths. So let's take a look at two ways to set up these proportions, because there are multiple ways that you can set up proportions and ultimately use cross products to solve here for different side lengths. So we've got shape A and shape B. Shape A is smaller than shape B, but both of them have a short side and a long side, which I've labeled here. Okay, so one way to relate these sides, these two shapes together, is by taking the short of A. Oh, hold on. Board decides to restart here. The short of A over the short of B and setting that equal to the long side of A over the long side of B. Okay? The short side of shape A over the short side of shape B. Set that equal to the long side of shape A over the long side of shape B. And just to give us some values to work with here, let's say that our short side of A is 6, and we'll say the long side of A is 15. Try and label them somewhat to scale there. And let's say the short side of shape B is 18. And the long side of shape B, we'll say, is 45. Okay? So using this first method to set this up, we're saying that we're comparing the short side of A to the long side of A. So the short side of A being 6, the short side of B. The short side of A being 6, the short side of B being 18, we can set this up, instead of using labels, use actual numbers, and compare 6 to 18. Right? I've just replaced the value of the short side of A with 6 and replaced the value of the short side of B with 18. And that's equal to the long side of A, which is 15, and the long side of B, which is 45. Okay? Why is that true? Being given these two fractions here, saying that 6/18 is equal to 15/45, what are a couple ways that we can prove that this is actually true? That these two fractions do equal each other? Yeah. Sorry? Okay, so 6 times 3 is 18, 15 times 3 is 45. Kind of using scale factor from top to bottom. Aiden?
You could divide both of the fractions and see if they're equivalent.
Okay, we can take the decimal values of each of these. And what decimal value do each of these have? 6/18 and 15/45. Okay, what fraction do they both simplify to be? which is another way that we could use here. What fraction do 6/18ths and 15/45ths both simplify to be, Pierce? 1/3. So because they simplify to be the same fraction, we know that they are in fact equal. What's the decimal value of 1/3? Aiden. 0.3 repeating. Okay, so the decimal values are equivalent as well. What's the last way that we could use to prove that these two fractions are indeed equal? We've talked about simplifying them. We've looked at scale factor. We talked about the decimal values. What's the other way? This one's kind of a big one because this is one that you could use where if you didn't know one of these sides, you could use it to solve for that missing side once you set up these fractions. Cross products, exactly. Okay. The other method we could use to set this up, there is a second way here. Rather than comparing short of A to short of B, we could also compare the short of A to the long of A. And what would our second fraction be? Kind of following this setup here. Yeah. The short of B to the long of B. Okay. Slightly different, but when we plug in the numbers here, we see it's still going to work out. The short side of A is 6. The long side of A is 15. The short side of B is 18. And the long side of B is 45. We could use any of the methods that we just talked about for the first one to prove that these two are equivalent as well. Scale factor going across from 6 to 18 and 15 to 45, we're multiplying each of those by 3. If we simplify these, we'll get 2/5 or 0.4 as a decimal. We use cross products. Any of those things are still going to work. Okay. Now the reason why I'm showing you two different methods here is I want you to notice something. Okay, if you haven't picked up on it yet in this unit, it's very important to pay attention to how you set these up because location matters. Notice that in both instances, the short and the long are either vertical or horizontally located, never diagonal. We don't ever have a short side in the numerator of the first fraction and the short side in the denominator of the second one, right? They're either lined up vertically in the same fraction or horizontally going across. The same is true for our A and our B. A lines up going across, B lines up going across, A lines up vertically, B lines up vertically. Nothing matches diagonally. Okay? And as long as you remember to set up your proportions with your units with nothing matching diagonally, short, 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 vertically, horizontally, good. A, B, B, horizontally, vertically, good. Nothing diagonal. Then you set it up correctly. Okay? Set it up correctly. Questions so far? All right, time for you to do a little practice yourself. Let's scroll down here. It says solve for the unknown side of the figure. Note it does say to show your work. I want to see the proportion that you set up. You can probably do some of these mentally. That's great. Okay, but I want to see the proportion that you would set up. Okay, so in this case, we're given rectangles, and we've got, we can label these shape A and shape B. We're given the short side of shape A, and we want to find the long side of shape A. Give me one possible proportion we could set up that will allow us to solve for this. And you can use X as your variable for that long side. What could we set up here? Connor? Okay, so method 1, and I'm going to kind of abbreviate here, but method 1 was the short of A over the short of B equal to the long of A over the long of B. Again, my short and my long, my A and my B, they match up vertically and horizontally, nothing diagonally. Okay, so what's the short side of A? What's the value for that? The short side, yeah, 10. So that's going to be the numerator. And then the short side of B is what? 15. And that's equal to the long side of A over the long side of B. The long side of A, that's what we're trying to find, right? So that's our variable, which we'll call X. And the long side of B, that's going to be 24. Right? That's one possible proportion you could set up if we use method 1. Short A or short B equals long A over long B. Right? Using cross products to solve here, what would we do to do that? How do we use cross products to solve here? The cross products method. Cross products method states that the product of the numerator of one and the denominator of the other, in this case 10 times 24, is equal to the product of the denominator of one and the numerator of the other, 15 times x. Right? We can do the left side, 10 times 24, and the right side we leave as 15 times x, which we write as 15x. Okay? How do we solve this for x now? Yeah. Yep. Divide 240 by 15, and we get a value of 16. So our value for the long side of A, what we were trying to find here, is 16. Okay? Let's look at the second one. We've got two trapezoids here. What value on those two trapezoids? We are given 4 values in our variable x here. Which value aren't we going to be using here? Which one can we just kind of cross out and ignore because it doesn't fit in with our proportions? Carly? The 24, right? We're not given this bottom side of our larger trapezoid, and so we wouldn't find that side to use it to find the side we actually want. We're just going to kind of ignore that. Okay? And we're dealing with the we'll call it the left and the top. You don't always have to use short and long, right? We can use the left side and the top side of these trapezoids. So, what can we use? What do you want to use, method 1 or method 2? G, a 1 or a 2? 1, very well. And so rather than short and long, we'll use top and left, I suppose. So we have the top of each shape, and we have the left side of each shape here, right? So using method 1 again, we're kind of lining up our lefts and our talls, okay? So the left side of shape A is what we're solving for. The left side of shape B is 25. And that's equal to the top side of shape A, which is 12, over the top side of shape B, which is 15. It kind of looks like this. We did left of A over left of B equals top of A over top of B. And again, notice nothing matches diagonally. That's how it's supposed to work, right? Our left and our tops align vertically. Our A's and our B's align horizontally. We know we're in business here, okay? Solving this. How would cross products work? Why don't you do it yourself? Practice it now. Pick it up from here. I'll give you about 30 seconds to use cross products to solve for that x side. It becomes difficult if you don't have a calculator. So if you don't have one, make sure you bring one for the test next week. What you want to be doing here, the numerator of one times the denominator of the other, which we again get 15 times x here, equals the denominator of one times the numerator of the other. All right, that's how you want to start this. And you should have an answer of 20. Okay, you should have an answer of 20. Gigi? No, it does not. No. If you put that in the front, then you get 20 equals x as an answer. You know, kind of like we did here. Right? It's the same thing. Everybody get 20 on your own? Good? Okay. Let's look at the second page. I'm going to have you do this first set of triangles here from start to finish. And before you begin, again, we're kind of given an extra value here. Well, actually, you know what? Yeah, I'll let you kind of decide where to go. So I'll pause the video for about a minute and a half, and we'll talk about answers when we come back. Someone bold and brave, give me the proportion that you use, not the answer, but the proportion that you set up here to solve this. Connor. 41. What is it? What are the actual numbers that you plugged in? Okay, 10 over 8 equals x over 4. We're comparing the left side to the right side of shape A, and the left side and the right side of shape B. 10 over 8 is x over 4. That will get you the correct answer. What's another one that you set up? Someone else. Leah. Okay. Similar to the first one here, right? We're comparing the left of B to the left of A, x over 10, and then the right of B over the right of A, 4 over 8. That will also get you the correct answer. Another one that folks set up here, Aiden.
14 over 7 equals 10 over x.
Sure. The bottom of A over the bottom of B equals the left of A over the left of B, matching up those corresponding sides. That will also get you the correct answer. There's so many different ways to find it, as long as you remember to match up your units vertically and horizontally, nothing diagonally. Ultimately, you end up with the answer of 5. And this is one that you could probably do mentally by saying, oh, wait a minute. Okay, 14 is double 7. 8 is double 4, so 10 is double of 5. You know, this shape on the right is half the size of the shape on the left. Maybe you saw that. Okay, it was set up intentionally to kind of recognize that, but I still wanted you to write these proportions down. Okay. Your homework for tomorrow, I do not want you to do that one, so you can X that one out. If you already did it, kudos, but not necessary. I would like you to do the 2 in the middle, note that this one here has an x minus 2. You might want to go back to CO42 to remind yourself how to solve using cross products when you've got extra stuff with that variable there. There's an extra step that we needed to do. So you might want to look back at PO42 if you need a reminder of how to do that. But this one here, both of these contain more information than you need, right? So you kind of got to pick and choose, decide what you want to use to answer the question. Skip this one down here, but I would like you to do this one. Last Christmas, I gave a life-size statue of myself to my wife as a present. She thought it was creepy, so I built a second one that was 2/5 as big as the first one, thinking it would then be only 2/5 as creepy. Turns out it was just as creepy as the first one. But if the original statue is 72 inches tall, how tall was the second one? Okay, so 3 of them to do for homework for tomorrow. In addition, before you pack up and chairs start squeaking everything, con is due tonight as well. Please get that finished, especially if you've got that on your bingo card. So con tonight and the rest of CO48. That's how you math.